Good afternoon. Today we are going to be working on some worksheets from 1.2, talking about designed experiments versus observational studies and bivariate data, which means we're comparing two variables together. And that's our little chapter 1 lesson that goes along with chapter 4. And then we're going to work on some chapter 4 worksheets, which is all about linear relationships. So I'm going to go ahead and share my paper here for everyone. So we're starting on page 410 in your course pack. It's worksheet from lesson 1.2, worksheet number 1, and I'm going to do question number 1 first. So it says, for each study below, determine the explanatory and response variable, whether it is an observational study or design experiment. If the study is observational, determine which type. Is it cross-sectional, case control, or cohort? So I would like you to pause the video for a moment and read through each one, A, B, C, and D, and make your best educated guess from what you understand. I would have your course back out and open from 1.2, and then we will catch you back here in a minute to go through each of those. Okay, so hopefully everybody's had a chance to go through each of these and give their best educated guess. And if you need a reference, page 31 in your course pack has all the definitions of the big content from this lesson. Now, this is not to be dismissed because it's from chapter 1, because we're going to talk about these definitions and this context for the entire semester. So the big overarching thing is, are we talking about an observational study, a study where you're just observing something that's probably already happened or is happening currently? Okay, a designed experiment is a thoughtfully designed experiment in which the researcher manipulates one or more explanatory variables. We call that a treatment. Not necessarily medical. And tries to determine how that influences the response variable. And the other thing is that these subjects have been randomly assigned into groups. So those two things need to happen to be a designed experiment. Okay. The two variables that we're working with, one is always going to be the response variable, the dependent measured variable, and the other one is going to be the explanatory or independent variable. Okay. So this first one here, I have the drinking as the explanatory variable. And the response variable is the disease. So that's where they measure the liver function. And just interrupt me, those on the live call, if you have any questions. And this one, there is no treatment. And this one would be considered a case control on this one. Okay, letter B, we're looking at skin damage here. And so the explanatory variable is the sunscreen. So some are wearing 35 and some are not. And this is a designed experiment. And the response variable that they're measuring is the skin damage. And we can tell that it's a designed experiment because there is a before and after. The teams were randomly selected to either be wearing sunscreen or not. And the sunscreen is the treatment. Letter C, the explanatory variable here on the blood pressure is healthy factors. And the response variable, the thing that they're measuring is the hypertension, blood pressure. And this was treated over several years, so it's definitely an observational study. And because it was treated over several years, it's a cohort. And the last scenario, the explanatory variable is the height. They're trying to say, Does the height predict the age of the person? And the response variable is going to be their age. And they did a random sample of 50 people, but they just measured their height and recorded their age. So it's definitely still observational, and this is a cross-sectional study. Any questions on that one?
No, I feel like it's something I can do when I have the definitions in front of me, but as soon as I'm not looking at the definitions of each of these things, I don't know.
And that's okay, because the great thing is you can have everything on that gray page. I really recommend, I'm glad you brought that up, Lo, is all of this I recommend having on your note sheet for the midterm. So there's things that are on that yellow sheet that are going to be helpful, obviously, and you'll want to make sure you don't overlap because that's using wasted space. But the midterm, you get 2 of your own 8.5 by 11 sheets, double-sided, whatever you want to write or type, highlight, section off, whatever you want. And all of these gray boxes are usually the ones that I point out that are really valuable to put on there.
And we get to use the yellow sheet on the midterm as well, you said?
Yes, ma'am.
Awesome.
Yep. Okay, then I would like to skip to 1.2 worksheet number 2. We're kind of skipping around, and if ever there's other problems on these worksheets that you kind of notice that you'd like to work on, go ahead and work on them and send me a message. I can address them at another live session, or we can plan a time to meet up on the Zoom and I can answer those questions for you as well. Okay, so question 2, I'm on page 413 now for those that are at home and watching the recording. This says, we have an article. This is 1.2. There we are. So the article is Tots TV watching causes increased risk of attention problems. Okay. So, describe the study that appeared in the journal Pediatrics. Researchers looked at records of 2,500 children who were participating in a long-term health study. That means it's observational, right? A long-term health study. There's no treatment. They found that children who watch more TV per week were significantly more likely to have an attention disorder. Okay. So, what is the explanatory variable? And it may be good for you all to take a minute and pause the recording before you move on with us. But so their explanatory variables, what do we think causes something else? And that would be the hours of TV watch per week. We think that it has something to do with the child having an attention disorder. Here is the response variable. Describe the most likely population. Notice this keeps coming up. What is the population? What is the sample? Your chapter 3 review worksheets. Make sure that you're paying attention to that as well. Those are due tonight. So the population is all children. That's who we want to learn about. The population is always who or what are you trying to learn about? And it always involves the word all. Describe the sample for this study. And that would be the 25 children studied. And this study is a what? We already mentioned that that's an observational study. And F says, explain with detail and context why it is important or improper, for the newspaper to give the article a title stating Tots watching TV causes an increased grudge of attention problems. So the word causes here is highlighted in bold because correlation does not mean causation when we have an observational study. Correlation does not mean causation. Observational study. So there's too many lurking variables that we did not account for, right? Lurking variables such as there could be genetics involved. There could be socioeconomic factors involved, right? With the TV watching and such. So you can only say that there's possible causation if you have a designed experiment. Okay. So while everybody is getting out their chapter 4 worksheets, I recommend getting them out in this order. Page 469 and page 478. And you'll notice that we're working with the same data set. And all of chapter 4 kind of goes together. And so I think it's great if we can look at one data set and kind of look at all of the context and all of the problem, all of the discussions around it, and then we'll go to another data set. So at the same time, go ahead and open your StatCrunch in your StatCrunch data group. So you can go ahead and grab the data for this problem. It is in our data and it's called percent literate, and it's 4.1 worksheet number 2 is where we're starting. And that's what it's called. And it's the variable is percent literate and then percent undernourished. So I'll give you just a minute to do that. Okay, so let's jump into this problem here. So what they did was they collected data. It says the table shows the percentage of the population who are literate in these various countries and the percent of the population who are undernourished. So we're thinking there's some relationship here, right? And you can see at the bottom of this first page is the, this is actually following, no, that's not the one I wanted to look at. So this is just question number 6 is what we're looking at. So I'm going to go ahead and show you a scatter plot, because in the scatter plot, we can also get this other stuff that we want. Because part A wants us to find the correlation coefficient, which is the R. I'll mark it back here. So we want to find the R, and I want to look at the scatter plot because that visual tells us something about what's going on. And then we can answer this question B, and then the R is going to lead us to question C and question D. Okay, so I'm going to share my screen so that you should be able to see my data. Lauren, can you see my data? I just want to verify that.
I can, it's just really small.
Okay, no, yeah, and yours, and you're going to be working with your own. So let me see if I can zoom this.
Also, I'm sorry if you can hear my dog snoring in the back. She's sleeping behind my computer.
Oh, nope, I can't. That's too funny. Okay, I made the data bigger here. So, okay, so we're going to go to graph, and I'm going to go down to scatter plot, because remember on the videos, I said the cool thing is if you do, actually, no, let's go to stat and regression, because on the YouTube videos, I mentioned if we do the simple linear regression, on the second page of the printout, it gives us a scatter plot. So it kind of gives us everything we want there. So I'm going to go here, and we're thinking that the percentage of the people that are literate in their country, so that's going to be our X variable, is going to have some relationship with the percentage of people that are undernourished. Okay, and so the only thing I'm really concerned about is just going down here, and everything that I want in my graphs and my model estimates, everything is all right there. So I'm just going to hit compute. You can do some fancy stuff, but there's no reason to. So I also, I brought this up big. Hopefully everybody can see this. I'm going to highlight, this is where you're going to find your equation that you're going to need for the projects for chapter 4. There's only one project, but this is the equation. And you're probably wondering, wait, there's no Y or X. This is the linear regression equation that it is calculating for us. So percent undernourished right up here, it tells us is the dependent, it's the Y. And over here, percent illiterate on the right is our independent, it's our X. And remember I mentioned on the YouTube videos that in StatCrunch, they give us the equations as Y equals B plus MX for some reason. So you can verify your slope and your y-intercept right down here where I'm circling. The thing we want first, though, on this worksheet on question number 6 is the correlation coefficient. So I'm going to highlight that right here. Our correlation coefficient is negative 0.69, negative 0.649. And let's just leave this up for a minute, and I'm going to go back to my paper, because that's going to be everything we're going to finish up on this problem here. So we just needed, and then we'll go back to that printout and StatCrunch. So the negative tells us something, right? B says, in general, if a country's percentage who are literate decreases, we would expect the percentage who are undernourished to what? So that's where I'm going to take you back just for a minute to StatCrunch, because I'm going to go to the second page. At the bottom right of your screen, if you click right, you can see can you see my graph here? So as we increase the percentage of people that are literate that can read, so over here to the right, these are the people that can read, where these countries have the majority of their populations in their country can read. They have a very low percentage of people that are undernourished. And so hopefully, right, if you can educate people in your country, they're going to be more likely to have jobs that can sustain them and provide nourishment and food, and they'll have money to buy food to take care of their families. So just because you can read doesn't mean that you're going to have food, right? It leads to other things. And so that's what this is saying here in the picture. Okay, so back to my paper. Hopefully that's giving everybody a better understanding here. So if the percent literate decreases, we would expect the percentage who are undernourished to increase. Because this is negative, they move in opposite directions, right? So we're thinking percent literate increases, percentage decreases on the undernourished. Okay, so based on the correlation coefficient right up here, describe the direction and strength of the relation. So we know it's negative, right? We know it's going to be in this bottom row. And then we have to go back to our yellow sheet to help us decide what level it is. It's 0.469, negative 0.649. So it looks like it's in here in this moderate. So it's a moderate negative. And D says, would the correlation coefficient be considered a parameter or a statistic? And that's where we have to look, because up here it says we have a random sample. I'm going to just point down here. That means that all of these are statistics. And you're just going to write a note. And that's because we have sample data. Remember, anytime it says explain on the worksheets, there's extra points for that. So make sure that you're answering all those questions. Okay. Excellent. That's the only thing I wanted to really spend time on. Yeah, we can do these last two real quick, even though it's not part of this data set. Number 7 says, which of the following could not be a correlation coefficient? Nothing related to our previous data, but we're going to just complete these since they're right here and easy to work on. Cannot be a correlation coefficient. Correlation coefficients cannot be over 1, right? They cannot be bigger than 1. So that's important. To recognize. That's the only one that could not be. We can have negative correlation coefficients, so the rest are all good. Number 8 says, what is the most likely correlation coefficient for the following engine data? So 2 things I'm looking at here. I'm noticing that it's positive relationship. As one increases, the other one increases. So I can cancel all of my negatives, right? And then I noticed that, you know what, the data is pretty good. Oh, and you know what, we can cancel this one that's over 1 because we know that it can't be over 1. And I think there seems to be a really good relationship here between these two variables. So this is the one that I would say we would choose, the 0.9. Any questions so far? Okay, so let's wrap up the last question surrounding this data set on literacy and undernourishment. So going to page 478 in your course pack, it's the same data set. So we're going to continue working with this relationship here. We can see that there's a moderate negative relationship going on. And it says find the least square regression model, which we did. So we can just go back to our that crunch here, which is cool. We've got it pulled up already. Is it showing you that? Well,
Yeah.
Okay.
Yeah, I can see it.
I can never tell what it's showing just because I've got the screens going. I just got my second screen last week, so I keep saying that, but I'm still fiddling with it. Okay, so I'm going to highlight. Here's our equation. We're going to write on our under letter A, percent undernourished is really Y equals 27.20. I'm going to just go to 3 decimal places, so 0.201 minus 0.208% literate is X. Okay, now I'll show you my paper here in a minute. Part B says, what is the slope? Let's fill it in before we explain it. Remember, on our printout here from StatCrunch, if you're unsure which is the slope and which is the y-intercept from your equation, it tells you right down here in the box. It says the parameter slope is negative 0.2076, and we're going to round that to negative 0.208. So you can fill that in for part B, negative 0.208. We'll interpret here in a minute. And then part C says, what is the y-intercept of the regression line? And in that same box right here in StatCrunch, we give you the intercept is 27.201. Okay, so I would like you to write those down, and I'm going to go back to my paper here so you can all see what I've written down. So there is my equation, and my equation is written in y equals b plus mx form because that's what comes out of StatCrunch. I filled in my slope and I filled in my y-intercept. So I'll give everybody a minute to do that. So part B says, what is the slope? We stated it, and it says, explain what it means in the context of the situation. So you're going to get out your yellow sheet, just like we did in the YouTube videos. And we give a couple different symbolic ways to explain slope, but our interpretation is what is most important. So if you told me here, when X gets bigger, Y gets smaller, I will not count that as a sufficient answer. Okay, so that tells me those that are watching the videos and paying attention to the videos, engaging with the worksheets, because I clearly go through these interpretations. On average, if X increases by 1, Y is expected to increase or decrease by approximately A. So the X is in quotes, Y is in quotes, because we're going to use our contextual variable here for X and Y. And then we're going to say decrease because our slope is negative. And then A is our actual value of the slope. Okay, so this is our X and this is our Y. So we're going to go ahead and write this on average, comma, if the percent literate of a country increases by 1, and I'm going to put my units 1%, comma, the percent of the country undernourished is expected to, and we're going to write decrease because our slope is negative, decrease by 0.208%. And then you wouldn't put the negative on that 0.208 because we already used the word decrease to describe the negative. Any questions so far?
Nope.
Okay, letter C says, the Y-intercept, which we wrote that down from our stat crunch, explain why the Y-intercept does not make sense in the context of this situation. Well, our Y-intercept says that we would have zero, when there's 0% literate, then we would have 27% undernourished. It's not likely, right? It's not likely that a country would ever have only 0% of their population literate, able to read. Would ever have 0% of population literate. Yeah, sometimes the Y-intercept is kind of silly, but we ask you to either explain why it doesn't make sense, or we ask you to interpret it either way, and just go ahead and interpret it even though sometimes it sounds silly. Okay. Letter D says 94% of Mexico's population was literate in 2017. What would the model predict is the percentage of people undernourished in Mexico during that year? Okay, so they gave us the X value for Mexico, right? So we can say Y equals 27.201. I'm using my equation and I am filling in 94 for X. I'm going to substitute this in. I want to bring this up because there's some calculations even in chapter 3 where folks are not typing there. You're showing like your upper fence and lower fence correctly, but your numbers are coming out incorrect. So if you have a graphing calculator, you can type it in just like this. If you're using Desmos, you can type it in just like this. If not, then you have to use your order of operations, which says you have to do this multiplication right here first, and then subtract from this 27.201. So I'm going to type it in just as it is. Okay, and I get 0.129, 0.129. Did I? I think I typed in something incorrect too. Oopsie, oh gosh, I know I have an error. Why is this not? What are you getting, Lauren?
I'm using my cell phone with the order of operations right now. So let me double check mine first.
What? Oh no, now I've got my. Okay, I had a digit that was not correct in my calculator. So 27.201 minus 0.208 times 94, just as it's written on my paper, should be 7.649. I had a digit incorrect. 7.649. The actual percentage for Mexico that was undernourished in 2017 was 3.6. Find the residual. So remember, there's a formula in our course pack for residual. It is the actual minus the predicted, and their actual percent undernourished was 3.6, and we predicted 7.649. And so our residual is a negative 4.08 or 4.0, actually 4.049 with what we have here, percent. So we over predicted, right? They performed better. They have fewer people undernourished than what we thought, which is great. So let's interpret that. So it says, what does the residual imply about how well Mexico is doing at feeding its citizens? So we have a negative residual. So the ones that say positive here, we can cross out. We know it's not 2. We know it's not 4 because they both have a positive residual. So it should be, Mexico appears to be doing a good job feeding its citizens since the residual is negative. It should be answer number 1. So that is a good thing. So how about we take a quick little break here. And when we come back, we are going to look at the next set of data in StatCrunch. So just below the literacy data, you're going to click on religiosity versus death anxiety. And that is going to be from page number 465 in your course pack. So we'll see you back for a little. So this is a little side suggestion for everyone here. That I would recommend going and finding all of your chapter review worksheets for all of the chapters and maybe putting those in a separate binder so that you know what ones you're going to be turned in every week or twice a week, right? And then what ones we're just working on during the live sessions. That might kind of help separate everything out. So chapter 4 pages, they're listed in JetNet, but it's page 483 through page 486 for chapter 4, if that helps. So let's go back to our second problem, that big problem that we're going to work on today. And it is this data right here on religiosity versus death anxiety. Researchers interested in determining if there is a relationship between being religious and if you have death anxiety. So subjects completed a checklist designed to measure an individual's degree of religiosity, and where a high score meant greater religiosity. And then they answer some questions about death anxiety. And a high score means they have high anxiety about death. Use technology to produce a scattergram for this data. Draw a quick sketch of it below, labeling your axes. We will in a minute. Let's first explain why this is not an experimental study. Well, the big thing is you can't make somebody be religious, right? So there's no treatment. And that's where, if you're wondering, you can ask yourself, if it's a design experiment, then you randomly assign people to groups and you gave them a treatment of the explanatory variable. And so that's why I always say, oh, can we make people be religious? No, silly. And so that's how we know it's not an experimental study. You cannot force people to be religious. Okay. And then it's asking us to compute the value of the correlation coefficient. So once we get our scattergram and what does it look like, we want to use our measure of that relationship, which is a correlation coefficient, and we're going to describe that relationship. And that'll give us a big picture before we move on to the second page of questions. So let's go ahead and get a scattergram. I'm going to share my screen here so you can see my StatCrunch. Hopefully everybody has their StatCrunch open to their death anxiety data. Here it is. So I am going to go to my stat and regression and simple linear, and religiosity is my X variable. Death anxiety is my Y variable, and I'm going to hit compute because that's all I need to do. And I'm going to go to my second page of the printout, and it looks like this is what our scattergram should look like. And I am going to just draw like a basic one on my paper. Religiosity is on the bottom horizontal axis, and death anxiety is on the vertical. And there are I'm just kind of drawing what I came up with. It's kind of trying to match up with what I have. I'll just show you what I did. I am not an artiste, so don't laugh. So the idea is we're just getting a visual. And then we can see that visually, it looks like there's a negative relationship, right? As religiosity gets bigger, death anxiety gets smaller. And so once we look at that R down here, we are going to assume that that should be a negative, right? That should come out to be a negative. So let's go sneak a peek back at our StatCrunch and see. So I'm going to go back to my first screen. And right here is my correlation coefficient. And by golly, it is a negative 0.804. And part D says describe both the strength and the direction. So it's definitely a negative relationship. And it's a strong negative because it's barely past the negative 0.8, right? So it's a negative strong. And then D says, is it reasonable to conclude that being less religious causes more anxiety about death? And remember, we can't say causes because it's an observational study. No, because this is not a designed experiment. And I will show you my paper momentarily, just to make sure we're all on the same with what we're writing down. And so this would be no, this is not a designed experiment. So we can't say that it causes anything. Okay. So if you turn to the other page, 470, right here, it also works with this data set, which is beautiful. And we can start answering some questions like this because we already have our StatCrunch done, which is awesome. So it says, what type of variable is religiosity? Well, it's definitely quantitative. We measured something, right? And it appears that we can't have a 4.5 measurement or 11.2 measurement. So this would be quantitative discrete. So it says compute the value of the correlation coefficient for these, which we did. And that is, we said that we listed it on the last one. It was a negative 0.804. State the linear regression equation. Well, go back to your StatCrunch. I'm going to go back there and I'm going to point out the equation, the slope, and the Y-intercept, just like we did last time, so that you all know how to find these things in StatCrunch, because you're going to need it for your project. I'm highlighting right here is the equation. Death anxiety is the Y variable and religiosity is the X variable. So we are going to write Y equals 42.111 minus 1.913 rounded times X. And in case you are still not confident about where the intercept and slope are, what they are, right down here is our Y-intercept, that validates that. And right here is the slope, and that validates that. And we're going to write them in their respective places. On part D is the slope, negative 1.913. And the Y-intercept is 42.111. Any questions finding those, Lauren? Well, okay. Let's go back to our paper, and now we get to do all the fun interpretation. So, again, right, just like any famous sports athlete or guitar player, you know, player of an instrument, anything that you're really good at, even any scientist, right? You practice how you want to play. And so that's why we always have our yellow packet right here to guide us, to make sure we're interpreting correctly. So we're going to interpret our slope and our Y-intercept using these right here. So it says on average, comma, if religiosity, remember, is X. So if religiosity score increases by 1, and there's no units on it, so comma, death anxiety is expected to, I'm using the word decrease again because our slope is negative. Now, all the examples we've done so far, the slope has been negative. It doesn't always work like that. It just happens to be in these examples, okay? So death anxiety is expected to decrease by, and you can use the words approximately, I forget that sometimes, so approximately the 1.913, and there's no units on that death anxiety measure either. Okay. Any questions so far on that one?
Nope.
Then E says, what is the Y-intercept? There it is, 42.111. What does it mean in this situation? We're going to use our yellow sheet to help us with the interpretation. So when X is 0, Y is expected to be approximately B. Remember, X and Y, we're going to put in our context. So when religiosity is 0, comma, death anxiety is expected to be approximately 42.111. And F says, using this model, what death anxiety score do you predict for a person with a religiosity score of 35? So they gave us an X value, right? That religiosity is an X. So we can say Y equals 42.111 minus 1.913 times 35. And put this into your calculator here. (42.111) minus 1.913 parentheses 35. Hold it up so that y'all can see it's at home. And we're predicting that to be a negative 24.844. And that doesn't make sense either, right? Because you could never have a negative death anxiety, but that gives us practice. Any questions so far on that?
I think it asks you why to explain.
Oh, right. Thank you. Thank you. Thank you. Explain why this result is not a reasonable prediction. Because you could not ever have a negative death anxiety value. No. So that's why that would be silly. Any questions so far?
No.
So let's go back and we'll check out what we have on our Google Doc. So we've covered 2, 3, 4, and 5. So number 6 says 4.3, worksheet number 2, problem 1. So we have not, the one last big topic that we have not really talked about is our coefficient determination, interpreting that, as well as our residual plots. So let's go to 4.3, worksheet number 2, problem number 1. And okay. And that's on page 481. I have to Google that here. Okay. So let's go back to that. So we're on page 481 here. So this says, does money buy happiness? No, money buys choices. I want to remind you all that. Does money buy happiness? A survey was conducted of different countries' people in 2005. The scatter plot below shows that the relationship between each country's annual per capita income in US dollars and the percentage of people in that country who called themselves happy. All right. So this is our scatter plot. And sometimes we give you a scatter plot and the equation right on the scatter plot. So if you're working on, say, the chapter 4 review worksheet and you see that I give you a scatter plot and there's no data and I start asking you questions about the slope and y-intercept, then you might want to look further on the scatter plot because I probably gave you the equation and the correlation or the coefficient of determination, which we did right here. Okay. So it says, what is the coefficient of determination? That's the R squared. And that's right here, 0.3918. It says calculate the correlation coefficient. So R is found by taking the square root of R squared. So the square root of this so the square root of 0.3918, which is 0.6259. What is the strength of the linear relationship based on the correlation coefficient? Got to get out my yellow packet sheet for that because I don't have it memorized. So the cool thing is we can use either of these as long as we're using the right number line, and we will be able to answer those questions. Okay, so R squared, if we use the coefficient of determination, the R squared, the 0.3918, we're going to be using this one down here that is only positive, because remember R squared is only a positive number, and 0.3918 means it's positive, it's a moderate. And if we use the correlation coefficient, which is 0.6259 and positive, we can see that from the scatter plot that it's going to be positive. We can look on that number line, and right here, 0.6258 will also be a positive, so, or a moderate. So don't worry, whichever one you're using, they will align the same. So this is a moderate positive. We're on page 481. Almost done with the activities. So it says, consider the residual plot of these data. Explain why it appears that a linear relationship was not appropriate for these data. So the residual plot, remember, we want it to be scattered. So let's write it down here. We want it to be scattered. But this one has a pattern. It has a cone shape. So it's got that cone shape going on, which says that when it's scattered on the residuals, it means that our error, right, is also scattered. And that's what we want. We want our error from the equation to be scattered and random. So it's just like the natural error that's going to occur. But this is showing that there is some predictable error that is in a pattern form, which means that the people that make less money, there's a fair amount of people that aren't happy, but there's a fair amount of people that are happy. But what it also shows is that as you make more money, it's more aligned with people being happy. So that's important to look at. So letter E says, if a linear relationship was not appropriate, which we said is not, what does this imply for the meaning of the slope and y-intercept of the linear regression equations shown in the scattergram? We can't use them. We can't use them to make predictions. For that reason. And for the sake of interpretation, I would like to interpret this coefficient of determination, because I don't think we brought that up on. Oh, let's, we're going to look at we'll look at another example where we do some interpreting. Do we have any questions on this page so far?
No.
So let's go back. I don't know what I have listed on the last thing on the Google Doc. I'd actually like to just go forward to 4.3 worksheet number 1. So let's go back to that. It's on page 479 on contraceptive versus fertility rates here.
Okay.
And I'm going to just change this in the Google Doc real quick here. So and let's just see what call is. We'll do that. We'll do all of it. And let's say page 479. Okay. So my computer, I think, is running slow with Zoom right now. Okay. So this is another example where we give you a scatter plot there's no data. I already gave you the linear regression equation. And in this case, the correlation coefficient, just the R, not the R squared, okay? So this data here is measuring contraceptive rate of women that are married of childbearing age and the fertility rate in births per woman. So it says, find the coefficient of determination. So make sure you are writing that down on your note sheet because students get mixed up. This interpretation for the R squared is the coefficient of determination. Okay, so this is the R squared, means we have to take R and square it. So we're taking a negative 0.754 and we're squaring that. And I got a negative 0.754 from right up here. It was in the scatter plot. And remember, StatCrunch will do that as well. So we're going to square that value. Calculators, 0.754 squared. And that comes out to be a positive 0.5685. And B says the relationship between contraceptive use and fertility rate. I mean, it looks like it's pretty good. Let's go ahead and put this in. So if we use the R squared, 0.5685, it's considered moderate, right? And if we use the correlation coefficient on negative 0.754, that would also show moderate. So remember I said they will always align. It doesn't matter which one you use. They will align with the moderate to moderate, strong to strong. And this is a moderate. C says, interpret the coefficient of determination in the context of the situation. So that's this. And we always interpret it in percentage form, right? From our yellow sheet right here. Formal interpretation. And this is your coefficient of determination. I'll probably write that on your note sheet too. So it says blank percent. So we already know that 56.85% of the total variation in fertility rate, because you're always talking about the Y variable, is explained by the least squares regression line. That's following our gold sheet. Any questions on that one?
No.
Following the gold sheet. Okay. Then if we flip the page, they gave us some residuals for this same data on the contraceptive use. So on this data, it says, consider the residual plot for these data. Explain why it appears a linear relationship was not appropriate. Again, it looks like it's cone-shaped. Okay, so if they're, this is the one time in math where a shape is bad. We want it to be random and scattered on the residual plot. That's our goal. Any questions on that one? And let's just do problem number 2 because we already had this data up from earlier. So I'm going to go back to that data. They're asking us to find the coefficient of determination, which we could actually just go back to our worksheet, right? Because we have the R squared, the coefficient of determination, R squared is found by taking R and squaring it. So let's go back. Let's go back to that page. That was a negative 0.649 was the R. And if we square that, we should get 0.421 or thereabouts, 0.421, 0.422, depending on what you started with a raw or not. And what is the strength of this relationship? Again, the correlation coefficient was a negative 0.649, which is going to be a moderate relationship. And they want us to interpret the R squared. So we're interpreting that number right there, this 0.421, which is 42.1% of the total variation in percentage of the population that is undernourished. Can be explained by the least squares regression line. Whew. We got a lot. That was good. That's all I had for today's class. We moved on a little bit quicker because there are just a couple of us on the call. Lo, do you have any questions?
Nope, not so far.
Okay, that's all I have. You're welcome to stay on. I think Arsenal had some questions on the chapter 2 thing that she's catching up on.